IPv6 addresses would be great if we could just squish them down a little bit. By the time we're done here, we will discover 2 rules. I don't know why I tickle myself sometimes. 2 rules that will significantly shorten our IP addresses. Yes, IP addresses are long. I should have made it like it's concrete or something. Anyway, they're long, and we have to find ways to shorten them. And the cool thing is, I'm going to be able to show you how to configure an IPv6 address on your Cisco router. It's going to shorten it automatically, and then we can talk about the rules it used and how we can use them to make it more effective. So obviously we have 2 IT administrators. Actually, those can't be IT administrators. They have ties on. But we have 2 characters posing as IT administrators who are flabbergasted at the length of the addresses that we now have to input into our routers. So let me grab my mouse and keyboard and head on over and get one configured and see what the Cisco router does. Now, you can see that I actually have this blue console cable right here plugged right into the Cisco 1921. It has an iOS image, which is a big deal, that supports IPv6. All right, so let's get logged into the router. There we go. I'm going to go into global configuration mode. Actually, hang on. Let's do a show IP interface brief real quick just to see. We, as of right now, just have one basic IP address on this router. Here's what I'm going to do. I'm going to configure the IP address using something known as a loopback interface. A loopback interface, if you haven't seen it before, is kind of like a test interface. Take a look at this. I'm going to go into global configuration mode, type in interface loopback, and hit the question mark. Take a look at that. 1 through 2,147,000,000, blah, 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 blah. I mean, you can have a trillion loopback interfaces. It's kind of a make-believe interface. You can actually use them for productive things. But for now, I'm just going to let's do loopback 0, just to create a dummy interface that we can assign an IP address to. You can see it says change state to up. I'll do IP instead of IP address, and you'll find this with a lot of the commands, IPv6 address. And the IPv6 address I want to assign is the one that I had on the screen with the 2 panicked administrators. It would be that guy right there. So I'm going to take that, copy it to my clipboard, and paste it in right there. Oh, and I pressed enter. So it's saying incomplete command. The reason why is it's saying I need the prefix added to that as well. That's essentially the CIDR-based subnet mask. Now, we haven't talked in detail about that at all. We're going to in probably the subsequent nugget. But for now, I'm just going to put a /64, which is a really common IPv6 prefix on there. Good. So now I'm going to come back and type in show IPv6 interface, and we'll do loopback 0. I want to see what IP address is assigned to that. Now, a couple things. This is good. Oh man, this is so good. This is going to be like the most amazing segue that we've got. So first off, when I say segue, this will lead us right into the next nugget, which is going to be the different types of addresses. It says, hey, I've gone ahead and put a link local address on here of FE80 blah, 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 a whole bunch of stuff, right? Then below that, we see the global Unicast address. Now, wait a second. Kind of looks like the one that we typed in right here, but it's not. Hang on, let's copy and paste that and stick it right on the monitor under the big one. Yeah, this one right here. So by entering this address right here, this is what we typed into the Cisco router, it automatically shortened it down to this address right here. That's substantial. So let's look at what it did. So first off, 2001, that's the same. That looks good. Okay, right here. This is where we have something happening. It looks like we went from 0010 to 10. So what does that tell you about the first rule of shortening? And by the way, look at the A right next to it. We went from 000A to just A, right? What do you think the first rule of shortening is? I'll write it up for you. You can drop leading zeros. These guys all went away. And if you're taking notes, underline that guy right there. Leading is key. You can't drop trailing zero. That's why you can see the 0 right here stays. It goes down. And if you think about how binary works, you just can't do that. You can't drop trailing ones because it changes the value of the number. So that offers a significant shortcut right there. But let's keep going. Okay, so 1001 stays 1001 because those are in the middle. It looks like 51 or 0051 became just 51 because of rule number 1. But then look at this. We ended up with this double colon. That would be rule number 2. You can replace running groups of zeros with a double colon, and I'm going to add on to that ... once. Look at what happened here. We took these two big groups of zeros and they became the double colon. And when I say we did, the Cisco router did that automatically. That can be a really substantial shortcut rule. And the reason I say that is, let me give you an example. And again, we're going to talk about some of these addresses in the next video. But the loopback address on a IPv6 format is actually all zeros, so 0:0:0, all the way down to the last one, which is 1. So a shortcut for writing a loopback address is actually : 1. That's a loopback /128. That's the subnet mask, which is the whole thing is essentially representing the host address. That is how we write a loopback address, is we take all those zeros and make them a double colon. Now why did I emphasize that once? Well, imagine you had an address that was this. Let's just go 0000:0000:0000:1111, right? :0000:0000. How many I get? 1, 2, 3, 4, 5, 6. And let's just do 1111:1111, right? So that's an IPv6 address. The reason that you can only substitute that double colon once is because, well, think about this. What does the computer know about an IPv6 address? How long does an address have to be? 8, right? It's 8 hextets. The computer knows it's always going to be 8 of these. So if we take out a group of these once, let's just say we replace those with a double colon, well, then it's able to look and go, okay, well, I only have 6, so this must represent 2 of them, right? But if you take out both of them and replace them with double colons, now it doesn't know how many zeros go in each location. You know, is there 5 here and none here, or 1 here and 4 there? And it doesn't know. So the best thing to do, just take off my changes there. The best thing to do is to go for the most bang for your buck. So if that's the most zeros, then go ahead and replace that with the double colon and just use the standard shortening rule for that. That can be shortened to 0:0, right? So that's good. In the end, this address could be shortened to this. There you go. Still long, but not as long as if we would have had to include all those zeros. Those are the 2 rules that can significantly shorten your IP addresses. I hope this has been informative for you, and I'd like to thank you for viewing.